In this video, we will discuss the polar form of complex numbers. Recall that the standard form of a complex number in a Cartesian or rectangular form is z equals a plus jb. Now, if z is a complex number, each complex number of this form can be represented in what you call a complex plane or an Argand plane. So this value here, a and b, again, recall that they are the real parts and imaginary parts of your complex number. This is associated with the ordered pair AB on the complex plane or Argand plane. And so we can always sketch the graph of the complex number z as a vector in the complex plane. Here, the complex plane is composed of a horizontal real axis and a vertical imaginary axis. And so, for instance, if you have your z1 to be 2 minus j5, this complex number is associated with the point 2, -5 on the Argand plane or the complex plane. And then z2 equals -2 is associated with the point -2, 0 on the complex plane. 0 because the imaginary part is 0. So you have -2, 0 as your point. z3 is associated with the point -4 on the complex plane. And j3 is associated with the point 0, 3 on the complex plane. So 0, 3, kasi in this case, sa Z4 natin, you only have J3, the real part is 0. So, the ordered pair is 0, 3. So, when we sketch the graph of these complex numbers on the complex plane or the Argand plane, we just simply locate the point associated with each complex number. So, for example, for Z1, that's 2, -5. So, 2, -5 is this point. So starting from the origin in the complex plane, you just throw a vector to the point AB. Okay, that now represents your complex number. Okay, so that's Z1. For Z2, that's -2, 0. So the point -2, 0 is here. Okay, so this is your Z sub 2. Your Z sub 3 is associated with -4, -4. So -4, -4 is here, this point. So Z3 is this vector. And Z4 is 0, 3. So 0, 3 is this point here. So your complex number Z4 will be this vector. So that's how you sketch your complex number in a complex plane or an Argand plane. Now, considering a complex number, again, z equals a plus jb. When we sketch the graph of this complex number in our complex plane, what we have is this point here, AB, and then from the origin, we can draw a vector to point AB on your complex plane. Now, for this given representation of your complex number, the length or the distance from the origin to point AB, on your complex plane is denoted by R, which is what you call the modulus of your complex number z, or it is also denoted by this symbol, so para absolute value of z, so that denotes the modulus of your complex number. And then from the positive x-axis, you can measure an angle from the positive x-axis measured in the counterclockwise direction to the terminal side of your complex number. We denote that by the symbol theta, which is what you call the argument of your complex number z. Remember that theta is always measured in standard position. Ibig sabihin, you always start your measurement from the positive x-axis, and then you go most of the time, no, what we give are are positive values of theta. So you go from positive x-axis, okay, ikot ka ng counterclockwise para you'll be able to get a theta or an argument that is positive and in standard position. So for this given example, we can draw a triangle. So basically, it's a right triangle in which this leg of your triangle corresponds to A, and this length or this leg of the triangle corresponds to B, right? So you have a right triangle in which R is the hypotenuse, A and B are the legs, and theta is the base angle. So if we will relate R, theta, and A and B, what we can have here is the relationship, okay, SOHCAHTOA, no? So using SOHCAHTOA, we will have the relationship cosine of theta is equal to adjacent over hypotenuse, or it follows that your A is equal to R cosine theta. And also, we can say that sine theta is equal to opposite, so that's B, over hypotenuse, that's R, or it's B equals R sine theta. So from the standard rectangular form, Z equals A plus JB, I can replace A by R cosine theta, and I can replace B by R sine theta. So from this expression, R is factorable, so you can have R times cosine theta plus J sine theta. This is now the polar form of your complex number. We have Z equals R quantity cosine theta plus J sine theta, or you can write that as Z equals R CJS theta. So ito yung shortcut, R equals Z equals R CJS theta. So CJS simply means cosine theta plus J sine theta. Again, R is the modulus and theta is your argument. Now, in solving for R, since you have only here a right triangle, if you are given the standard form in rectangular coordinates, so A and B are known, you can solve for R by just simply using the Pythagorean theorem. So basically, the formula in solving for your R is just the square root of A squared plus B squared. Okay? So sa rectangular form, ang kailangan mo is A and B. Sa polar form, ang kailangan mo is R and theta. But you can solve for R and theta by using the A and the B given dun sa rectangular form. Now, some remarks: the polar form of a complex number is not unique, right? Because there are infinitely many values that can be used for theta. So, halimbawa, kapag meron kang complex number na Z equals, let's say, 2 CJS 45 degrees. Okay? Kasi yung theta mo can be represented in radian measurement or pwede rin naman naka-degree measurement. So kahit alin doon, pwede mong ipag-represent ng iyong argument theta. So let's say 2 CJS 45 degrees. The 2 CJS 45 degrees is also the same as having Z equals 2 CJS 405 degrees. Why is that so? Kasi yung 45 degrees at saka yung 405 degrees, they are just coterminal angles. Ibig sabihin, umikot ka lang ng isang buong ikot. Okay? So kung ito yung 45 degrees, pag umikot ka ng isang buong ikot, mula dito, iikot ka ng 360, ang terminal side mo ay yun pa din. Okay? So yun pa rin complex number na yun. Okay? So same R, same pa rin yung iyong terminal side. So basically, iba lang yung measurement ng argument, theta, pero you ended up in the same terminal side. So basically, you have the same complex number. Kaya, what we do is we just choose our argument or our theta from 0 to 2 pi. So, hindi na natin siya iniikot ng isang buong ikot kasi infinitely many yun. So, para meron lang tayong isang unique na sagot for the argument, we choose only from 0 to 2 pi yung ating theta. So, if that's so, then we say that theta is the principal argument of z if the measurement of theta is only from 0 to 2 pi. So, from 0 to 360 degrees. And if r is greater than 0 and theta is a principal argument from 0 to 2 pi, we say now that z equals r cjs theta is in standard polar form. Okay? And the standard polar form now of a complex number is unique. So, again, the polar form of a complex number is not unique kasi yung theta mo pwedeng maging marami na possible values. Iikot mo lang ng iikot ng isang 360 degrees ay magbabago na yung value ng theta. So, meron ka ng panibagong polar form. Pero kung standard polar form ang pinag-uusapan, ang standard polar form ay unique. Ibig sabihin, iisa lang. Kasi ang theta mo, kukuhanin mo lang from 0 to 2 pi. Hindi mo na siya kailangang iikot ng multiples of 360 degrees or 2 pi. Now, let's have some examples. You want to convert 1 plus j to standard form. So, this one is given in Cartesian form. So, the first step is to solve for r. Okay? So, tingnan muna natin nasaan yung ating complex number. So, pag in-sketch natin yan, yung 1 plus j is associated with the point 1, 1 on the complex plane, right? So, pag ginraph natin, 1, 1, okay, this is our complex number. And so you have the point 1, 1 associated with 1 plus j. So on the origin plane, we plot 1, 1. And then from the origin, we draw a vector, okay, to the point 1, 1. So this is r, the length, from the origin to 1, 1. And your theta is this principal argument theta. So you have here r to be equal to the square root of, again, this one will be your right triangle. So this is 1 unit, another 1 unit. So that's 1 squared plus 1 squared. Or that will be r equals the square root of 1 plus 1 or square root of 2. So that's your modulus. Now to solve for theta, we can use arctan. Theta is equal to arctan opposite over adjacent. So arctan 1. So theta is equal to arctan 1, which is equal to pi over 4 or 45 degrees. So please recall the trigo function values of special angles. Okay, so since calculators will be not allowed during the prelim period, make sure that you memorize kung ano yung sine, cosine, tangent values ng mga special angles, pi over 3, pi over 4, pi over 6, okay, and other special angles. So here, arctan 1 is pi over 4. And so, z equals 1 plus j can be written in standard polar form as z equals the square root of 2 cjs pi over 4. So, yung pagkuha ng trigo function values, no, it's important that you memorize, no, yung mga special angles from 0 to 2 pi kasi nga our principal argument is from 0 to 2 pi. So, ayan yung list ng mga special angles from 0 to 2 pi in degree and in radian measurement. Eh, basta, ang importante lang naman when you try to memorize, no, you can start with the angles in quadrant 1. So, halimbawa, dito, ang sine ng pi over 3 ay square root of 3 over 2. Ang sine ng pi over 4 ay square root of 2 over 2. Sine ng pi over 6 or sine ng 30 ay 1/2. When it comes to quadrant 2, Okay, yung mga multiples ng pi over 3, pi over 4, at pi over 6, ayan pa rin yung mga values niyan. Okay, same. So, sine 2 pi over 3 is square root of 3 over 2. Sine 3 pi over 4 is the same as sine pi over 4 square root of 2 over 2. Sine 5 pi over 6 is same as sine pi over 6. That's 1/2. Okay, pagdating sa quadrant 4, okay, recall ASTC, yung sign ng mga trigo function values. Sa first quadrant, lahat, all are positive. Sine, cosine, tangent are positive sa first quadrant. Sa second quadrant, sine lang ang positive. Sa third quadrant, tangent lang ang positive. Sa fourth quadrant, cosine lang ang positive. So kaya, yung values ng sine, doon sa first quadrant, puro positive. Sa second quadrant, dahil ang second quadrant, sine ay positive din, kay sine theta is also positive, puro positive din. Pagdating sa third quadrant, negative na yung values ng sine. Ay, sa fourth quadrant, negative din. So, ibig sabihin nito, ang sine 4 pi over 3, parehas sa value ng sine pi over 3. Pero, dahil nasa third quadrant, negative. So, negative square root of 3 over 2. Yung sine pi 5 pi over 4, parehas sa sine pi over 4, square root of 2 over 2, pero dahil nasa quadrant 3, negative na siya, square root of 2 over 2. Si 7 pi over 6, sine 7 pi over 6, same value ni sine pi over 6, pero dahil nasa quadrant 3, negative 1/2. Ganon din sa 5 pi over 3, 7 pi over 3, 11 pi over 6. Pag sine theta ang kukuhanin, since nasa fourth quadrant yung mga angles, you will have negative square root of 3 over 2, negative square root of 2 over 2, and negative 1/2. Pagdating sa cosine, cosine pi over 3, mababaliktad lang, no? So, ito naman yung 1/2, tapos ito naman yung square root of 3 over 2, yung pi over 4, square root of 2 over 2 din. Sa second quadrant, dahil negative ang cosine sa second quadrant, same pa rin yung set of values dito, pero negative lang. Negative, negative, negative. Sa third quadrant, ganun din. Negative din yung cosine doon. So, same numerical value, pero negative. So, negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2. Sa fourth quadrant, dahil positive na yung cosine sa fourth quadrant, positive values na yung meron ka. 1/2, square root of 2 over 2, and then square root of 3 over 2. Pagdating sa tangent, ang kailangan nyo lang gawin ay kuhanin yung ratio. Diba? Tangent is sine over cosine. Tama? Therefore, kung sine over cosine yung tangent, pag kinuha ko yung tangent pi over 3 or 60 degrees halimbawa, i-divide ko lang yung sine 60 sa cosine 60. So, square root of 3 over 2 divided by 1/2, you only get square root of 3. Pag kukuhanin ko yung tangent ng pi over 4, i-divide ko lang yung sine pi over 4 sa cosine pi over 4, which is just 1. Right? Pag kukuhanin ko yung tangent ng pi over 6 or tangent 30, so that's just 1/2, divided by square root of 3 over 2, or that's 1 over square root of 3, or that's square root of 3 over 3, and so on. So, kayo na bahalang mag-fill in nung table na to hanggang sa dulo. Okay? Now, let's have another example. Convert 2 minus j2 in standard polar form. So, here, we again sketch the graph first. 2 minus j2 is associated with the point 2, negative 2 on the Argand plane. So, pag ginraph natin yan, you will have here on quadrant 3, this is our, that's quadrant 4 rather, yung ating 2, negative 2. So, 2, negative 2 is this. So, this is our terminal side. Okay, that's your complex number. So, R is this length. Okay, R is simply the square root of 2 squared plus 2 squared. Okay, kahit na hindi na natin ilagay yung negative dun sa sign, okay lang. Total, we are squaring naman. So, kahit na hindi natin ilagay yung negative, we'll still get the same answer. So, this one, yung right triangle kasi natin, we have 2 units here and then 2 units here. Okay? And then our theta, again measured from the positive x-axis counterclockwise, will be this one. Okay? So sa case na to, yung theta mo nasa labas ng triangle. So what we do is we solve first for what you call the reference angle. Yung nandun sa loob ng triangle, no? Yung acute angle na nandun sa loob ng right triangle natin. So let's denote that by alpha. Mula dito hanggang dyan, that will be your alpha. Okay? So that's the reference angle. So yung alpha muna yung solve natin using arctan. Okay? So laging arctan ang gagamitin to solve for the alpha kasi yun yung nasa loob ng triangle mo. So alpha is equal to arctan. Okay, opposite is 2, adjacent is 2. So you have 2 over 2, or you also have the arctan 1. So again, arctan 1, so that's pi over 4. So since alpha is pi over 4, to solve for theta, ano ang gagawin natin? Therefore, theta is simply 2 pi minus alpha. Okay? Kasi yung isang buo, mula dito hanggang dyan, 2 pi, hanggang dito, 2 pi. Pero i-minusan mo ng alpha para matira si theta. So, 2 pi minus alpha, you'll get 2 pi minus pi over 4, or that's simply 8 pi over 4 minus pi over 4. So your theta is 7 pi over 4. Therefore, z equals 2 minus j2 can be written in standard polar form as z equals, okay, your r is, hindi pa pala natin tapos yung solve yung r. So r is the square root of 4 plus 4, or that's the square root of 8. Or square root of 8 is 2 square root of 2. So that's 2 square root of 2 Cj is 7 pi over 4. Next, convert to polar form negative 1 minus j square root of 3. Okay, this one is associated with the point negative 1, negative square root of 3 on the Cartesian plane. So, I draw natin yan. Nasa third quadrant. So, you have here negative 1, halimbawa, negative square root of 3. So, this is your point. Okay. So, solving for r, r is equal to the square root of, okay, so your triangle is this. You have here square root of 3 units and then 1 unit. Square root of 1 squared plus square root of 3 squared. Or that's r equals the square root of 1 plus 3. So r is equal to the square root of 4, or that will be equal to 2. Now in this case, our principal argument will be this one. Okay? From positive x-axis measured counterclockwise, papunta dun sa terminal side. So, again, nasa labas siya ng triangle, no? Yung buong theta nasa labas ng triangle natin. Ang meron lang sa loob ng triangle, we denote that by alpha. Okay? So, yun muna ang ating reference angle. Okay? So, para magamit natin yung formula na arctan opposite over adjacent, kailangan yung angle mo nasa loob ng triangle. So, for this, alpha, okay, is equal to arctan. So, ang opposite mo ay square root of 3. Ang adjacent mo ay 1. So, that will be, hindi natin sinasama yung, yung negative sign. Okay? So, kung ilang units na lang siya. Okay? Yung length, okay, nung bawat side nung triangle natin, yun na lang ilalagay natin sa pag-solve ng ating angle. Okay? So, that's square root of 3 over 1. So that will be arctan square root of 3. So anong angle yung merong value ng tangent na square root of 3? So going back to yung table natin kanina, that will be pi over 3. So that's pi over 3. Therefore, okay, if this is pi over 3, para ma-solve natin si theta mula dito hanggang dyan ay pi. I-add natin si alpha, makukuha natin si theta. So, theta is equal to pi plus alpha. or that will be pi plus pi over 3. So that's 3 pi over 3 plus pi over 3, or that's 4 pi over 3. Therefore, z equals negative 1 minus j square root of 3 can be written as z equals 2 CJS 4 pi over 3 in standard polar form. So in general, kung ang ating complex number has terminal side on the first quadrant, so ito yung R, ito yung theta natin, diretso yung ating theta ay makukuha natin as arctan opposite over adjacent. So wala na tayong kailangang gamitin pa na alpha na reference angle. Okay, kasi yung triangle natin na magagawa, nasa loob na mismo si theta. Okay, yun na mismo yung angle sa loob ng ating triangle. Kapag nasa second quadrant, yung ating terminal side, yung theta natin ay ito. Ang triangle natin na magagawa is this. Okay? So, kailangan natin again gumamit ng reference angle na alpha. So, masosolve natin si alpha muna, and then to solve for theta, theta is, so, itong buo na to, 180, so that's pi, minus mo yung alpha, masosolve mo yung theta. Pag nasa quadrant 3 naman, yung ating given complex number, yung terminal side, this one will be your theta, principal argument. Again, ang ating triangle na mabubuo is nandyan. So, gagamit tayo ng alpha. So, this is alpha. And so, theta is equal to pi plus alpha. Kasi, itong isang buo ay pi, 180 degrees. Ipa-plus mo yung alpha, makukuha mo ng buo yung theta. Then, lastly, kapag nasa fourth quadrant, yung ating terminal side, ito yung ating theta. Okay, principal argument. So, your triangle is this. So, gagamit tayo ulit ng reference angle alpha. And then, solve for alpha. To solve for theta, we need to subtract alpha from 2 pi. Kasi isang buo, ito, that's 360 or 2 pi. Yung minus mo tong alpha, matitira will be your theta. Okay, so yan yung general cases na pwede natin ma-encounter. Now, what is 2 in standard polar form? Yung 2 ay real number lang, right? So, in standard form, yung 2 natin is actually 2 plus j0. So, pag sinolve natin yung r niyan, that's the square root of 2 squared plus 0 squared, 2 rin yung magiging modulus. Now, pag ginraph natin yan, ang z equals 2 is just this. Okay? Horizontal, okay, along the positive x-axis. At ano yung angle niyan? Okay? Hindi natin kailangan isolve kasi obviously this one has theta equal to 0. 0 degrees or 0 rad. So therefore, z equals 2 in standard polar form is z is equals to CJS 0. Okay? Likewise, if you have negative J4 as your z, this one can be written as z equals 0 minus J4. If you solve for your modulus r, that's the square root of 0 squared plus 4 squared, that's 4. And pag ginraph natin yan, this is associated with the point 0, negative 4 on the organ plane. So, pag ginraph natin yan, nandito yan, negative 4. Okay? Vertical, no? Pababa. At ano yung angle niyan? Mula dito, pag ganyan, this is 3 pi over 2. Or it's 270 degrees. Therefore, z equals negative j4 in standard polar form is z equals 4 CJS 3 pi over 2. So kapag yung iyong graph nung complex number mo is just purely horizontal, ibig sabihin real yung ating complex number, real number, or kapag naman vertical, ibig sabihin pure imaginary, pwede tayong magkaroon ng shortcut, no? If A is an element of the set of real numbers and a is greater than 0, kung ang form ng complex number mo is z equals a, then the polar form, standard polar form is z equals a CJS 0. Kapag z equals ja, that's z equals a CJS pi over 2. Pag z equals negative a, that's z equals a CJS pi. Pag z equals negative ja, you have z equals a CJS 3 pi over 2. Okay? Now, we want to write square root of 3 CJS 150 degrees in rectangular form. So, ito baligtad naman. Okay, rectangular form, given polar form, gagawing rectangular form. So, what you do is, you expand this as, diba, square root of 3 CJS 150 is also square root of 3 cosine 150 plus j sine 150. Kasi yung CJS shortcut lang siya eh. Pero ang long form niyan ay r quantity cosine theta plus j sine theta, right? So, pwede nating palitan ito ng ganyang form. And then, what we do is we just simplify yung nasa loob ng parenthesis by putting in the exact values. Okay? So, what's the value of cosine 150 degrees and what's the value of sine 150 degrees. So from our table, okay, na ginawa a while ago, your cosine 150 degrees is negative square root of 3 over 2. So this is equal to square root of 3 times negative square root of 3 over 2 and then plus j. Sine 150 is positive 1/2. Okay? So that's equal to square root of 3 times negative square root of 3 over 2 plus j square root of 3 times 1/2. Or that's negative 3 over 2 plus j square root of 3 over 2. So that's now the rectangular form of your complex number. Next, write 6 CJS negative 3 pi over 4 in rectangular form. So note that this complex number is not in standard polar form. Bakit? Kasi negative yung angle sa loob. But still, okay, depending, based on the given, we have to write it in rectangular form. So ganun pa rin, i-expand natin yung CJS. Okay, we will write that as, so 6 CJS negative 3 pi over 4, we will write as 6 times quantity cosine negative 3 pi over 4 plus j sine of negative 3 pi over 4. Now, recall that the cosine of a negative angle is equal to the cosine of the same angle but positive, and sine of negative angle is equal to negative of sine of the positive counterpart of the angle. Therefore, if I have cosine negative 3 pi over 4, pwede ko itong isulat as cosine positive 3 pi over 4. And then if I have sine negative 3 pi over 4, I can write this as negative sine 3 pi over 4. So, magiging minus na ngayon yung sine dito, j sine 3 pi over 4. Then, we just plug in the exact values of cosine and sine 3 pi over 4. So, cosine 3 pi over 4 is negative square root of 2 over 2. And then sine 3 pi over 4 is positive square root of 2 over 2. So minus j square root of 2 over 2. Simplifying further, distribute, you will have here negative 3 square root of 2 minus j 3 square root of 2. Now, there is a shortcut in multiplying and dividing complex numbers if they are already written in polar form. Okay, kasi kapag the standard na Cartesian form or rectangular form, we use FOIL method, we use conjugate, and so on. Pero kung meron tayo ay naka-polar form, we can multiply and divide complex numbers in polar form. So, the product of Z1 and Z2, if Z1 is R1 CJS theta 1 and Z2 is R2 CJS theta sub 2, is just equal to the product of the modulus or moduli rather of the two complex numbers CJS sum of the arguments theta 1 plus theta 2. For division, Z1 over Z2, Okay? The quotient is simply the ratio or the quotient of the moduli R1 over R2, and then CJS, difference of the arguments, theta 1 minus theta 2. Also, if Z equals R CJS theta, then the complex conjugate Z bar is simply R CJS negative theta. So, ine-negative mo lang yung argument, yun na yung polar form nung conjugate ng iyong complex number. Halimbawa, you want to evaluate 2 CJS 50 degrees, okay, times 4 CJS 130. So, what we do is we multiply in terms of polar forms. Okay, this is just equivalent to 2 times 4 times CJS 50 degrees plus 130 degrees. So multiply the moduli and then just add the argument. So this is 8 CJS 180 degrees. Now, since we want this to be in rectangular form, halimbawa, yung final answer natin, ang gagawin natin, expand natin to as 8 cosine 180 plus j sine 180. And then, put the exact values of cosine 180 and sine 180. Cosine 180 is negative 1. Sine 180 is 0. So, wala na yan. Therefore, our final answer is negative 8. If you want to divide 10 CJS 7 pi over 6 over 5 CJS 2 pi over 3. So what we do is we divide the moduli 10 over 5 and then CJS, subtract the argument 7 pi over 6 minus 2 pi over 3. So that is 2 CJS. So this is 6, LCD is 6. 6 over 6, 1 times 7 pi, minus 6 over 3 is 2 times 2 pi, that's 4 pi, or that's 2 CJS 3 pi over 6, or that's 2 CJS pi over 2. In polar form, this is 2 cosine pi over 2, or rectangular form rather. In rectangular form, so this is 2 times cosine pi over 2 plus j sine pi over 2. Exact values of cosine pi over 2 and sine pi over 2. For cosine pi over 2 is 0. Sine pi over 2 is positive 1. So this is 2 times j1, or this is j2. If you have integer powers of complex numbers, okay, the following properties apply. Let z be equal to a complex number and n be a natural number. Then z raised to n is equal to z times z times z times z up to n factors of z. Z raised to 0 is equal to 1 if z is not equal to 0. And z raised to negative n is equal to 1 over z raised to n if again z is not equal to 0. And if n is a natural number and z is r CJS theta, then if we want to raise z to the power of n, then it means that you'll be having r CJS raised to n. So that's r CJS theta times r CJS theta times r CJS theta up to and so on up to r CJS theta. So up to n powers of r CJS theta. That is equal to r raised to n times CJS theta plus theta plus theta plus theta and so on. Kasi ang mangyayari dyan ay magmumultiply, di ba? Magmumultiply lahat ng moduli, r times r times r times r and so on. Tapos mag-a-add lahat ng arguments. Okay? Kasi yun yung shortcut natin para sa multiplication ng polar forms. So, etong r times r times r times r magiging r raised to n. And then yung theta plus theta plus theta plus theta and so on magiging n times theta. And so, if you raise z to the power of n, okay, that's equal to r raised to n CJS n theta. Or, we can write this as r CJS theta raised to n is equal to r raised to n CJS n times theta. This is now what you call the Moivre's theorem. Okay, the Moivre's theorem. Evaluating a complex number that is raised to an integer power n. For example, you want to evaluate negative 1 plus j raised to 16. Obviously, we have to start always with the polar form of the complex number. Okay? Because again, the Moivre's theorem, ang base niya is RCJS theta. Okay, so polar form. So if what you are given ay standard na rectangular, we have to first transform that to polar form. So negative 1 plus j is associated with the point negative 1, 1 on the complex plane. So graph natin yung negative 1, 1. So negative 1, then 1. So nasa second quadrant yung ating terminal side. We can solve for r as the square root of 1 squared plus 1 squared, or that's square root of 2. So here our triangle is this. So yeah, 1 unit and then another 1 unit. Your argument, principal argument is this one. Okay, so you have to first use a reference angle alpha and then solve for theta from there. So alpha is equal to arctan 1 over 1, or that will be arctan 1. So alpha is pi over 4. And since nasa second quadrant, no, if you go back to our generalization kanina, pag nasa second quadrant yung ating terminal side, we can solve for theta as pi minus alpha. So in this case, you will have pi minus pi over 4, or that's 4 pi over 4 minus pi over 4. So it's simply 3 pi over 4. Therefore, z equals negative 1 plus j raised to 16 can be written as square root of 2 CJS 3 pi over 4 raised to 16. Now, using the Moivre's theorem, you will now have the square root of 2 CJS 3 pi over 4 raised to 16 as equal to square root of 2 raised to 16 CJS 16 times 3 pi over 4. Right? So, you have r raised to n times n, or CJS n times your theta. So in this case, simplifying, you will have 2 raised to 1/2 times 16, because the square root means raised to 1/2. Okay, CJS 16 over 4 is 4 times 3 pi, you have 12 pi. So that's 2 raised to 8, CJS 12 pi. But what is 2 raised to 8? 2 raised to 8 is 256. So this is 256 CJS 12 pi. Now we can simplify this further because 12 pi, okay, ilang ikot yan, no, multiples of 2 pi. Okay, so basically 256 CJS 12 pi can also be written as 256 CJS 0. Right? Because 12 pi is coterminal with 0. Iikot ka lang ng 6 na beses, babalik ka sa 0. Therefore, this one can also be written as negative 256 in rectangular form, because cosine 0 is 1 and sine 0 is 0. Sorry, this one should be positive 256. Positive 256. So cosine 0 is positive 1 and then sine 0 is 0. Next, simplify j raised to 59 times 2 CJS 32 degrees raised to 5 all over 8 conjugate of CJS 50 degrees and express it in rectangular form. So what we do here is we first simplify j raised to 59 is remainder 3. Okay? So j raised to 59 is remainder 3. Therefore, j raised to 59 is negative j. And then the 2 CJS 32 degrees raised to 5 can be expressed using the Moivre's theorem as 2 raised to 5 CJS 5 times 32 degrees, or that is 32 CJS 160 degrees. And then the conjugate of CJS 50 degrees is equal to CJS negative 50 degrees. Okay, pag magko-conjugate tayo sa polar form, ini-negative lang natin yung argument. So pag pinagsama-sama natin ulit yan sa isang expression, we will now have negative j 32 CJS 160 divided by CJS negative 50. Now, it will be better kung lahat sila naka-polar form na. So, ipo-polar form natin si negative j. Ano yung polar form ng negative j? So, from our generalization previously, kapag pure imaginary, ang magiging standard polar form will just be R CJS 3 pi over 2, or that's 3 pi over 2 is 270 degrees kasi negative itong ating r dito. So in this case, you will have here, or no, not r, negative yung sign nung ating complex number kasi yung ating negative j ay pababa, paganyan. Okay? So this is negative 1, so pababa siya. Okay, kaya yung angle mo is 270 degrees or 3 pi over 2. So, pwede mong palitan si negative j ng CJS 270 degrees. Since naka-degree yung angle natin dito. Times 32 CJS 160 divided by CJS negative 50. Now, simplifying further, yung numerator, since product yan, pwede mong i-multiply. You will have 32 CJS 270 plus 160 and then divided by CJS negative 50. Continuing further, yung 270 plus 160 is 430. Okay? Yung may 8 pa pala dito sa baba. Okay, so you have here 8, so I forgot the 8 here, so that's 8. And then you also have 8 here, you have 8 here. So continuing further, you will have 32 CJS 430 degrees divided by 8 CJS negative 50 degrees. So pag pinag-add mo yung 270 plus 160, so that's 430. Okay, so divide na ngayon, you'll have 32 over 8 CJS 430 minus negative 50. Okay, so you have now difference now ng arguments, which is 4 CJS 480 degrees. Now, since 480 degrees is greater than 360, pababain natin siya. Okay? So, pag pinababa natin siya, ang gagawin nyo lang, maminusan nyo lang ng 360 para pabalik. No? Pabalik na ikot. Para yung angle mo is from 0 to 2 pi kasi gusto natin standard polar form. So, pag maminusan ko to ng 360, this is equivalent to 4 CJS 120 degrees. Now, since ang gusto natin ay naka-rectangular form, you write this as 4 cosine 120 plus j sine 120. But what is cosine 120? Cosine 120 is negative 1/2 from the table. And then sine 120 is square root of 3 over 2. So j square root of 3 over 2. Distribute the 4. You will have negative 2 plus j 2 square root of 3.